Good morning. Welcome to today's lesson on solving two-step equations. Last time we saw all the different ways we could solve one-step equation, and I shouldn't say all, we skipped over square roots. There's probably even other things that we didn't do, but we looked at the basics: adding, subtracting, multiplying, and dividing. So now we're going to do two-step equations, and we're going to put those operations together in different ways. So today we're going to be solving two-step. Remember, we're going to get all the way up, I can't spell today, all the way up to 5 steps this year. Maybe even throw a 6-stepper in every once in a while just to challenge you. But solving a two-step equation involves either adding, subtracting as one of the steps, and multiplying or dividing as one of the steps. There's even a time when we could just see multiplying and dividing as the 2 steps and one of each. Okay, so let's start with a very basic problem. Okay, 3x plus 4 equals 25. Okay, now again, I know some of you are already thinking, I can do that in my head, I've already got the answer, I know what it is. And again, I'm going to say to those people, I don't care. I need to see the steps. Okay? Right? This is where I just, I cannot stress this point enough, that showing me how you got your answer is infinitely more important to me than what the answer is. Now, there are obviously 2 things happening in this problem. We have 3 times x, so we're multiplying here, plus 4, we're adding. Okay, so we have 2 operations here that we need to undo. Now the question that really comes up is, what order do we undo them in? Now we know, if I ask you what order do we do things in, the order of operations, you should tell me we do parentheses and exponents, and then we multiply and divide, and then we add and subtract. But that's the order of operations. I want to undo it, so I'm going to use something called the inverse order. Getting ahead of myself there. The inverse order of operations. Lots of O's. Inverse order of operations. Now, what is that inverse order? Here's the part you got to keep in mind. The inverse order is P, parentheses. Wait a minute, isn't parentheses the start of the order of operations? It is. Its whole purpose. What is a parentheses purpose in life? To tell you to deal with it first. That is its goal. That's its purpose. So parentheses still comes first, even in the inverse order. Then we remember, oh wait, what's the end? Oh, that'd be adding and subtracting. We're going to say subtracting and adding. Doesn't matter, they're the same thing. We've seen that. If I don't like subtraction, I'll change it into addition by putting some cheese on it. What's up next? Multiply and divide. Oh yeah, there we go. So divide and multiply. Again, those are the same thing. If I don't want to divide by a fraction, I multiply by the reciprocal. Multiply and divide are the same, add and subtract are the same. Do not give them different preferential treatment. And then the last one would be the exponent. And we're going to deal with that eventually, but not for a little while. Okay, we're going to really stick right around in here, in these top 5. Okay, I like it because it allows me to say, poor, sad me. Easy to remember, right? We love those mnemonic devices where we can just say something and then that reminds us the whole thing. Poor, sad me. Parentheses, subtract, add, divide, multiply, exponent. Easy peasy. So if I grab this, and the nice thing is you can use this as either what I need to do or what I see is happening. Doesn't matter, I'll just react to either one. And this is the other thing I've been saying, okay? So those of you that, oh, I already know the answer. Stop knowing the answer. Stop even thinking about the answer, okay? Simply react to what you see and then deal with it. Usually we deal with it by doing the opposite. Now, that's not the case with the parentheses. It's not the case when there's variables on both sides, but we will deal with it. So it's looking at what's happening in the problem and reacting and then making a decision. In fact, if we do that, we'll find that we don't need to do a lot in the math arena. It'll all be simple, basic stuff, I can go get a third grader to go help me with the math part, as long as I know what needs to get done and exactly when it needs to be done. So I look over here and I say, hey, are there any parentheses in this problem? No. Is there any subtraction in this problem? No. Is there any addition in this problem? Yeah, right here, I added 4. How do I undo add 4? What's the opposite of add 4? Subtract 4. And this is exactly how I want it to look, boys and girls. Exactly how I want it to look without exception. So you may need to find yourself a place to do this that isn't on the worksheets that you're working on. You might need to go find a separate sheet of paper because you need some space. Because now that we're doing 2-step equations and I need to see both steps, it's write the problem, step 1, step 2, and an answer. That's going to be 4 lines you're going to need. You're going to need some room to do this. So this is now 0. Positive 4 and negative 4 make 0. So this is gone. And you don't need to cross it out or anything. I'm just doing this for emphasis. Leaving me with the 3x. 25 minus 4 is 21. Now I go back to my little list. I was at addition. Next down would be division. I don't have any division in this problem. Multiplication. Hey, I do have some multiplication. I have 3 times x. Well, what's the opposite of multiply by 3? Divide by 3. Now, what did I ask? I asked my third grader to do 25 minus 4. First grader can do that. And 21 divided by 3. That's where my third grader needs to be a third grader. And they gave me all the answers. All I needed to know was what order to do things in and specifically what to do. Okay? That's what you're looking for when you see these 2-step equations, is what's happening in the problem, and then what do I need to do? What am I going to do when I get to that moment? When I say, oh, hey, I see some subtraction. This is my cue to add. Oh, I see some addition. This is my cue to subtract, and so on. Which one comes first? What order do I do those things in? I follow the inverse order of operations, and I do them in the opposite order that I was presented them. Okay? All right, let's look at a couple more quick little examples here. Again, I'm going to put my little inverse order up here just to keep, so I have something to keep referring back to. And maybe, let's see, how about x divided by 2 minus 4 equals 9. And I find that these are ones that, this is another one of those times when students suddenly go, well, I don't just immediately know what the answer is. Okay? So that's fine, because we don't need to know it. All I'm doing is going, are there any parentheses? No. Is there some subtraction? There sure is. And the opposite of minus 4 would be plus 4. As we stated, these are going to zero out, and I'm going to be left with x divided by 2 equals 13. Is there any division? Yeah, there is. How x divided by 2, the opposite of divided by 2 would be to multiply by 2. Or if you remember from the last lesson, maybe I would even I could cross multiply here if I wanted to. Especially if that were a fraction, I might do that. It might be another step I have to add. For now, I'm just going to multiply by 2 because these are going to reduce, and that's going to give me my answer, x equaling 26. Okay? So, and if I took my 26 back up here and I used the order of operations and did it in the right order, I'd go 26 divided by 2 is 13. 13 minus 4 is 9. Yeah, it would. Okay? Now, one of the main reasons I want to be able to do this is, again, I'm starting with very simple numbers. Easy numbers. Whole numbers. What if I gave you, oh, how about 3x minus 2 equals 9? To me, this doesn't look any harder than the one right above it, but I assure you, for some of you, it is. Because you're not sure, because when you start to approach it, you go, hey, there's no parentheses. There is some subtraction, so I'm going to add 2. There's no addition. There's no division. There is multiplication times 3, so I'm going to divide by 3. And what's 11 divided by 3? Well, it's a repeating decimal. I'm going to leave it as a fraction. But you'll notice for me, I was no harder than the one right above it. All I had to do was add 2 to 9 and then say, and I didn't even have to do it. I just said, I'm going to divide by 3. I'm going to take 11 and divide by 3. But if I said, what's the answer? This is where students go, well, I don't know. And those are the ones I'm talking about. Those are to you are the students that I'm talking about where you're like, oh, that one's so easy. And then you get to this one and it's not any harder. Same 2 steps. It's just that the answer is 11/3, which is not obvious and not something that you just go, I already know the answer, it's 11/3. Huh? Okay? And that's because too many students get so hung up on the answer and stop worrying about the process. Okay, remember, step by step, this is easy as it gets. I'm going to show you a 3rd step later on. We're going to add a step to after that. 4th step, we're going to add a 5th step. And I'm telling you, if you just go, it's all about this. I love this phrase, and it drives some of my students crazy, but I love it. Don't think, react. Look at the problem, see what's happening, and react to it. Hey, I see subtraction, I'm going to add. I see division, I'm going to multiply. Okay, I see subtraction, I'm going to add. I see multiply, I'm going to divide. Okay, we'll talk about what, obviously, when we see parentheses, we're going to do that distributive property that we learned last week or the week before. We learned it before. That's what we're going to be looking for. When I see that, I'm going to react to that, and this is how I'm going to react. Okay? Okay, that is what we are looking for when we are solving 2-step equations. Okay? And again, it's just the idea that someone has come along, taken our number, and done a couple of things to it. And when you do things forward, using the order of operations, you undo them backwards by following the inverse order. The exception is that that big P is still parentheses. And it's oftentimes turns into the distributive property that we learned. Okay? Simple example, like I said, I like to look at it as like stacking things. If you're stacking things on top of other things, on top of other things, and then you say, okay, I want to know what's on the bottom. You don't just yank it out from the bottom. You remove the things in the exact opposite order that you put them on. Okay? And then you get back down to what's at the bottom of whatever it is. And that's what's going on. We took x, we divided by 2, we subtracted 4, and we got an answer. Now we're going backwards, and we found out that we really started with 26. Okay? So that's solving 2-step equations. That's what I'm looking for, and I'm going to be looking for the work, the steps. Okay? Now, I'm going to show you one more example that actually, I think I'll show you 2 more. Because these are ones that really trip people up. What if we put things, if we put things first, for example, what if I said, oh, how about 5 plus 2x equals 14. Okay, so things have gotten a little bit out of order because I put the variable second. Okay, I could even put it on the other side if I wanted. Yeah, let's do that. I'll do both. Let's look at it in both ways. Let's write it this way. What do I do? Well, okay, so I'm still adding 5. So that means I'm going to subtract 5. I'm still multiplying by 2, so I'm still going to divide by 2. And you can leave it as a fraction, or if you really want to, you can turn it into a decimal. Don't turn it into a mixed number, please. We really don't use mixed numbers much anymore at this point. Mixed numbers either have to turn into decimals or improper fractions. So again, just keep it as either an improper fraction or a decimal, but not a mixed number. Okay? One more example to show you. Almost exactly the same, but really messes students up a lot. What if I gave you that problem? Okay? Students invariably want to add 5. That's not the right thing to do. So let's make sure we understand this. This is where maybe, you know what, I'm going to write this a little lower just so I can write something on top of it. because this negative sign is with the 2x. So here's what I'm going to do. I'm going to put my cake, I'm going to put some cheese on it, keep the 5, switch this to addition, change that to its opposite, which makes it negative. So what I'm actually going to do here is I'm going to still subtract 5 because this is a positive 5. Remember, you want this to become 0. Whatever it takes to make that become 0 is what you want to do. If it were a negative 5, I would add 5, but it's not. It's a positive 5, so I'm going to subtract. That's going to leave me with negative 2x equaling 9, and when I divide by negative 2, x is going to get me negative 4.5 or negative 9/2, depending on which way I want to do it. Okay, I don't know if you have any of those in tonight's, but you will have it, if not this week, next week for sure. All right, I hope this is helpful, and again, show your work, show your work, show your work, and I will see you again in office hours.